Welcome to the Walton Pi. Today we're going to go through an implicit differentiation problem. If these sorts of videos are helpful, please consider liking and subscribing. It helps me to keep making them. So here we go. Let's get started. So if we are given something like if y is equal to inverse secant of 4x minus 3 plus 2 pi, what is y prime? Or dy dx. How would we find that if this was the problem we were given? Well, the way we're going to have to do this is either you have the derivative of inverse secant memorized, which I don't, or we're going to have to use implicit differentiation. So how would we do that? Well, the way we're going to start is we are going to begin with this and try and rewrite this to get rid of the piece that we don't know what to do with. And that piece is the inverse secant. So we start with y equals inverse secant of 4x minus 3 plus 2 pi. We need to try and get rid of that inverse secant. So we're going to want to do secant of both sides, but the problem is this plus 2 pi that we have left over. So we're going to first subtract that over. So we get y minus 2 pi is equal to inverse secant of 4x minus 3. And now we can do secant of both sides, and we get secant of y minus 2 pi is equal to 4x minus 3. And at this point, we have successfully gotten rid of the inverse secant, which is the piece that was causing us problems. So what we're going to do is this is the piece we are then going to be taking the derivative of both sides with. So let's go through and say, well, I'm going to take the derivative with respect to x of this entire thing. Well, what's the derivative of secant with respect to x? Well, just secant of x, what does that go to? Well, the derivative of secant is secant x tangent x. So that means that this side we will get a secant of y minus 2 pi times tangent of y minus 2 pi. And then we are going to be multiplying all of this by the derivative of the inside. And the derivative of the inside is that dy dx that we were looking for. So that's what we got on one side, but then what's the derivative of 4x minus 3 with respect to x? Well, that's just a 4. Great. That's really, really nice and handy for us. So now the question is, what are we going to do from here? Well, we want to solve for dy dx. And so when we do that, we get dy dx is going to be equal to 4 divided by secant of y minus 2 pi tangent of y minus 2 pi. And at this point, we want to get rid of all of the y's. We want to solve this so it's in terms of x's. Well, we're going to be using this fact right here. Y minus 2 pi is inverse secant of 4x minus 3, which when we were to put this into a triangle, remember this tells us that secant of y minus 2 pi is equal to 4x minus 3. So if we had this on a triangle, here's our angle of y minus 2 pi. Secant is 1 over cosine, so that's 1 over cosine. Cosine was adjacent over hypotenuse, so that's 1 over adjacent over hypotenuse, so this is hypotenuse over adjacent. So that means this side is 4x minus 3 and adjacent is 1. So then this last side is going to be the square root 4x minus 3 squared minus 1 squared. So we have all of that, and now we can figure out what's tangent of all of those things. So when we go through and put all of this together, we get a 4 divided by secant of y minus 2 pi, secant hypotenuse over adjacent, so that's going to be a 4x minus 3, and then tangent is opposite over adjacent, so that's going to be a square root of 4x minus 3 squared minus 1, and that is going to be our final answer. The derivative of that function is this. And that is how you would go through and do this type of an implicit differentiation problem. I hope this was helpful. If it was, please consider liking and subscribing. It helps me out a lot with my channel. And I hope you all have a great rest of your day, and good luck with all of your math.